In this section we are going to look at chemical oxygen demand measurements, how to do them, what we are measuring, and what we may use the data for. A chemical oxygen demand test is done by mixing a sample containing reduced organic carbon with oxidation chemicals and heating it at 150 degrees centigrade to allow for complete oxidation. One of the reaction products changes the sample color, which can then be measured with a UV VIS spectrophotometer. The value for COD is calculated from the absorbance data of the instrument. When we've taken a wastewater sample, a COD measurement can be done from the whole dispersed sample, with the result being an equivalent mass of oxygen, COD, of all four the organic fractions in the sample. The fractions are biodegradable soluble, inert suspended, biodegradable settlable, and inert settlable. Letting the sample settle, a COD measurement of the supernatant will give the sum of the fractions, biodegradable soluble and inert suspended, which may be a more accurate estimate of the BOD equivalent expected from a BOD5 analysis. When we take a wastewater sample at the start of the process, point 1 on the diagram, the sample contain all four the organic fractions of pollutants as described previously. During the aeration phase, all the pollutants come in contact with the biomass culture and are transferred to the biomass. The fractions of solids in the wastewater transfer to the biomass with different efficiencies, and the COD measurement of the final effluent, point 7, will give a good estimate of the overall performance of the process, removing the pollutants. The different transfer efficiencies of the fractions in the wastewater sample cause the change in the mass per volume percentage fractions, shown for the final effluent sample. This was a demo video presentation extracted from a training module for wastewater treatment process by RES Enviro.